Welcome to The Explainer. We are diving straight into the developer trenches today, unpacking part 123 of the Notes on Haskell programming series from April 30th, 2026. Now, if you've been following along with our journey of generating PDF ebooks from text files, you know we've got the foundational mechanics working. But today is all about the workflow. We're talking about those absolutely crucial quality of life improvements and taking a really fascinating look at how our underlying coding philosophy actually evolves when we're forced to refactor. Let's get right to it.
I want to start with a scenario that I think, pretty much every developer knows entirely too well. What happens when your Haskell script works perfectly, but the workflow is still driving you absolutely crazy? Picture this. You just built this brilliant method for generating PDF ebooks. The code compiles, the text converts flawlessly, but then you have to manually dig through your file system, locate the new directory, and double-click the generated PDF just to check your work, every single time. It's that tiny bit of repetitive friction that over 100 development iterations just completely wrecks your flow state.
Okay, let's dive into this, because the most elegant solution is literally staring us right in the face. Just automate the open. The practical goal of today's source material is adding a seamless cross-platform auto-open feature. The idea is that the exact moment your file finishes converting, boom, it should just pop open automatically in your OS's default viewer for immediate testing and review. Sounds incredibly simple, right? But as you'll see, integrating this smoothly into an existing Haskell toolset actually brings up some really interesting architectural choices.
All right, let's jump into section 1, automating the workflow and implementing the code.
So let's look under the hood and trace exactly how this gets wired in. To make this happen, we basically need to tell our Haskell program to go talk to the underlying operating system. As we can see in the source diff, there are 3 main steps. First things first, we got to add the process package to our package.yaml dependencies. Without that, we simply can't spin up those external viewers. Second, we bring in the heavy hitters by importing system.process, specifically for the call process function, and control.monad. And finally, we update our core args data type by adding a brand new Boolean field, which actually leads us right into how the user triggers this whole shebang.
Which brings us to section 2, the flag naming dilemma. You know, writing the base code to talk to an OS is one thing, but exposing that feature to the user, actually designing the command line interface, that is where the real struggle begins. And this brings us directly to our new flag. We clearly mapped that new open after Boolean field in our code to the --open flag, or just -o for short. When a user passes this in the terminal, it tells the OS to pop open that default viewer upon a successful conversion. Simple, logical, clean, right? Well, hold on a second. Think about standard CLI conventions for just a moment. If we claim -o for our new open flag, what happens when we inevitably need an argument to specify an output file name? Usually, -o is the universal, undisputed standard for output, and we've kind of just stolen it. This perfectly highlights an incredibly frustrating yet completely normal dilemma that CLI developers face literally all the time.
Now, what's really interesting about the slide is how accurately it exposes the universal developer pain of mapping CLI flags. As our programs grow and get all these exciting new features, we quite literally run out of short alphabet letters. Finding logical alternatives is really tough. Do you make output -f for file, -d for destination? The author rightly points out that this scramble often leads to unintuitive shortcuts that are virtually impossible to remember. And when shortcuts don't map naturally to a user's mental model, your tool just becomes frustrating to use. It's a fantastic reminder that writing software is honestly just as much about understanding human psychology as it is about getting the syntax right.
Moving on to section 3, academic versus industrial Haskell. As we move past the CLI interface and look at the core logic implementing this auto-open feature, the source material actually zooms out to share a broader, profound philosophical realization the author had while refactoring. To handle the conditional logic of whether to open the file based on that CLI flag, they brought in the when utility. I love this quote from the source. The when utility function from control.monad provides a readable alternative to standard if-then-else blocks. It elegantly skips all that unnecessary else boilerplate. If you've ever found yourself trapped in deeply nested, right-drifting conditional logic traps, you know exactly how valuable a clean when statement is for keeping your codebase nice and flat.
And this brilliantly illustrates a core stylistic showdown within the Haskell community. The author realized their initial implementation relied heavily on what's known as academic-Haskell.
We're talking a strict focus on brevity, reliance on cryptic alphabet soup, extracting tuples with FST and SND, and long, mind-bending chains of the $sign operator. Contrast that with industrial Haskell. The industrial approach champions clarity above all else. It uses explicit naming, relies on elegant pattern matching instead of FST and SND, and hey, it isn't afraid to break complex operations down into multiple, highly readable lead blocks.
The ultimate takeaway from this whole refactoring session is right here. Industrial code makes the logic much easier to digest. By actively choosing the industrial mindset, rewriting those cryptic academic operators into explicit pattern matching and clear variable names, the author concluded that the resulting codebase is far easier to read, maintain, and share with others. Brevity might feel clever in the moment you type it, but clarity is the absolute key to keeping a project alive over the years.
So, as we wrap up this explainer, I want to leave you with a final provocative thought. Think about the code you've written this past week. Ask yourself, are you writing code just to satisfy the compiler, or are you writing code for your team, your users, and your future self? Do your natural habits lean toward the clever brevity of academic coding, or the robust clarity of industrial coding? It's an essential question for any developer looking to level up their craft. Thanks so much for joining me to unpack these notes and keep exploring the why behind how you code.